lecture for today, we'll have to answer a few example problems in addition with the pre-recorded lectures para madagdagan naman yung example na naibigay ko doon. So, dalawa yung example na ibibigay ko. So, hopefully, ma-cover natin yung dalawa. So, medyo mabilis po ito ng konti. Then, participate as much as possible, everyone. Kindly participate. So, we have here a simply supported beam with a cantilever span beam or with a overhang beam. Require now for us to draw the shear and moment diagram. The shear at point C, as shown here, which is basically 5 meters from the hinge support, and the equivalent moment due to the applied loads or applied dead loads at point D, which is the location of your ruler. And lastly, the point of zero shear. Okay, I hope you have already watched the lectures on regarding the difference between the point of zero shear and the point of inflection. The point of zero shear defines the point on the beam span where there is no equivalent shear force. Okay, and the point of inflection refers to the point along the span of the beam where there is no tawag na dito, moment. And that particular inflection defines also the location of your maximum deflection later on. So with this, let us try to expand first the lines that we have here for your shear in moment diagram. Extend ko lang. Okay. Now, on our given figure, we have now a uniformly distributed load of 10 kilonewton meter at a total span of 7 meters on our beam. Hinge support at point A and a roller support at point D, and a varying load starting from 15 kilonewton per meter to 0 from point D to point E of 5 meter in span. Then another dead load of 5 kilonewton 1 meter from point A and 6 kilonewton dead load 5 meters from point A as shown here. Concentrated 5 and 6 kilonewton uniform. Then we have here also the ito yung ating varying, ito yung uniform load, ito naman yung varying, and ito naman yung ating concentrated loads. Okay? Now, anong una nating isosolve? First things first is for us to identify whether the given beam is, tawag na dito, statically determinate or indeterminate beam. So, don't worry, this lecture is recorded para mapanood nyo ulit mamaya. So, for us to determine that, how are we going to identify the degree of determinacy of a beam? How? R defines the reactions based on the supports on the beam, and 3 times N defines the number of parts. So, how are we going to do that? Hanapin muna natin yung ating reactions. On our hinge support, as you probably remember from your truss, analysis of truss structures, we have, again, we have two reactions on our hinge support. Okay, horizontal, vertical, and one perpendicular reaction at the roller support. Okay, this is your AH and your AV, then your RD. So, plot it off on your equation for determining the degree of determinacy. Number of reactions 3. It is a single span beam. There are no internal hinges along the span of the beam. So, that is only one part beam. So, given that it is now 0, so basically, this is now a determinate beam or statically determinate beam at 0 degree. Okay? So, anong susunod natin gagawin dyan? Is for us now to identify the what? Anong susunod? Identify the anong susunod? Anong susunod? Reactions. So how are we going to identify the reactions? By summating moments due to the applied loads on a specified points. So saan nyo gusto mag-summation moment? So support. Oh, so let's go with summation moment at point A. Summation moment at point A equal to 0, clockwise forces positive or resulting forces positive. Okay? Unahin muna natin yung concentrated kasi yun yung pinakamadali at saka yung ating reaction at point D. Okay? How far does the concentrated load of 5 kilonewton is at point A? So, gaano siya kalayo? 1 meter. Moving clockwise, counterclockwise. Pwede nyo pong buksan yung inyong mic para mas mapabilis tayo. Participate people kasi if you don't participate talaga, hindi nyo talaga maintindihan. Clockwise, counterclockwise. It is now moving clockwise. So positive. We have the dead load of 5 kilonewton. Lagay ko na lang yung unit towards point A. And a moment arm distance of 1 meter. Ano pa yung concentrated? We have also the concentrated load 6 kilonewton located at point C, which is 5 meters from point A, also clockwise. So plus 6 kilonewton times what? 5 meters. And your reaction at point D. The reaction is point D, assumed to be upward. Moment arm distance towards point A, counterclockwise. So RD towards point A. How long was that? That is 7 meters. Now, determine now the resultant force of the uniform load and the varying load. Uniform load, varying load. Hanapin lang natin yung centroid ng uniform load at saka ng ating varying load. Centroid ng rectangle. Anong centroid ng rectangle in terms of length? Of course, the half of length. So, ito yung ating resultant dito, which is half of its application. So, half of 7 meters, that is 3.5 meters from point A. Okay, we still need to solve the R of the uniform load. Then, the varying load. The varying load. Centroid of the varying load is what? 2/3 from point E. 2/3 of 5 meters. And here is 1/3 of 5 meters. Okay? Then, i-add na lang natin yung total moment arm distance towards point A. So, how are we going to do that? The uniform load has an equivalent load of 10 kilonewton per meter. Or yung ating resultant towards point A clockwise. So, positive 10 kilonewton per meter. Span of application is what? 7 meters. Para matanggal si meters dun sa ating kilonewton per meter. Then, moment arm distance ni resultant ni uniform load towards point A, half of 7 is 3.5 meters. Rectangle naman kasi siya. Then, ganun din si varying load. Varying load is what? 15 kilonewton. Ano yan? Triangle. Area of a triangle. That is 1/2 base times height. So, area of a triangle count clockwise. That is 1/2 of 15 kilonewton per meter. Base of 5 meters. Moment arm distance towards point A is 1/3 of 5 meters plus 7 meters equal to 0. Nakuha po yan kung paano Ito yung sa uniform load. Ito naman yung sa varying load. Ito yung sa concentrated loads. Nakuha?
Yes, sir.
Varying loads, okay? Then, equate that to 0 to form an equilibrium. To put it in equilibrium. So, simplify. Simplify ko na. Dire-diretsuhin ko na. 5 times 1. Baka pati yan, di nyo pa makuha. 5 times 1 plus 6 times 5 plus 10 times 7 times 3.5 plus, limutan ko yung plus, 1/2 of 15 times 5 times 5/3 plus 7. Okay? Nagets po kung saan nakuha yung plus 7 ha, na moment arm distance for the varying load. Naintindihan?
Yes, sir.
So, with a total of 605 kilonewton minus RD of 7 equal to 0. Transpose, divide both side by 7, reaction at the roller support, 605 divided by 7, we have 86.429 kilonewtons. Okay? So, anong gagawin naman natin dun sa ang tawag na dito, reaction at the hinge support? Para mas mabilis tayo, do we have an actual force applied on our beam? Do we have an actual force? Horizontal force. So we don't have horizontal force. So by summation forces horizontal, we can then immediately solve. Going to the right, positive. AH is now equal to 0 kilonewton. And lastly, of course, by summation forces vertical or forces acting on the vertical axis equal to 0, upward, positive. What are the forces acting on the vertical axis? We have the concentrated load of 5 kilonewton downward, so minus. Then minus the another 6 concentrated load, 6 kilonewton downward as well. The resultant of the uniform load, which is 10 kilonewton directed downward, kilonewton per meter, applied at a total span of 7 meters. Para constant tayo sa unit, matanggal yung meters, so we'll have kilonewton. And the varying load downward as well, area of a triangle, 1/2 of 15 kilonewton per meter, span is 5 meters. And the reaction at the roller support upward, which is 86.429 kilonewton. And lastly, your AV equal now 0. Okay, don't forget to equate that to 0 to put the system in equilibrium. -5 minus 6 minus 10 times 7 minus 1/2 of 15 times 5. Okay? Okay. Gives us, no, -5 minus 6 minus 10 times 7 minus 1/2 of 15 times 5 plus 86.429. Gives us 32.071 kilonewton. Negative 32.071 transpose, we have AV positive 32.071 kilonewton. Don't worry if you're going to use the full decimal places of your answer. Ang discrepancy lang natin probably 0.001 or 0.002, something like that. For as much as possible, try to use it this way. So we have now the vertical reaction at the hinge support of 32.071 kilonewton. So ilagay na natin yan dun sa ating figure. AH is equal to 0. So kung ang AH is equal to 0, there is no actual force, which is probably more or less lagi lang nasa frame structures. So there is no actual force, meaning there will be no normal diagram. Okay? So hindi na natin kailangang i-drawing yung ating normal diagram dahil wala namang actual force. Then we have vertical reaction AV of 32.071 kilonewton upward. And reaction at the roller support also upward of 86.429 kilonewton. Nababasa po ba kahit papaano? Okay lang? Readable?
Yes, sir.
Okay. So first things first, if the problem asks you later on to draw the normal diagram, as you can see here, there is no actual force applied on our beam system. So the normal diagram, which is more or less in kilonewton in unit, should then be equal to 0. So ganyan lang yung normal diagram natin later on. Then kailangan nyo kasi yan, lalo na sa frame. Okay? Then, next stop is for us to plot our shear and moment diagram. How are we going to plot our shear and moment diagram? Identify your positive ordinate and your negative quadrant. Your positive quadrant and your negative quadrant. All the forces identified above the line of the shear diagram, which is in kilonewton, are positive. All values found below that line is negative. Okay? Set na natin. I'll be using color dark blue. So note that there is a vertical force. There is a vertical force at the hinge support upward. So that should also be reflected on your shear diagram, which is an equivalent value of what? Equivalent value of 32.071. Kaya na lang po mag-tansya yan later on. Ito na lang. Ito atang maano. Yeah. Let's just say at that point that is already 32.071 kilonewton. Okay? Then note at a 1 meter distance there is already a uniform load of 10 kilonewton. How are we going to do that? From 32.071 minus the area of the uniform load within 1 meter. So that is 10 kilonewton per meter times 1. So, using your calculator, hindi ko po kasi mailagay lahat dyan. Hindi kasya sa aking screen. 32.071, sulat nyo na lang, minus the uniform load, 10 kilonewton per meter at a span of 1 meter. At a span of 1 meter, ito yung tinutukoy ko, 1 meter. So 32.071 minus 10 times 1 is 22.071. Okay? Bababa siya. Dahil yan ay nasa 0 degree, so our next figure should be in the first degree ng 22.071 kilonewton. And note, there is a concentrated load found 1 meter from the hinge support. So from 22.071, ibawas natin ulit yung concentrated load na 5 kilonewton. Minus 5 gives us 17.071. 17.071 kilonewton. Then, from that point up until to the 4 meter span, meron tayong uniform load. So 17.071 minus 10 kilonewton per meter times 4 gives us negative 22.929. So from there, meron tayong negative 22.929 kilonewton. And again, note there is still a concentrated load 5 meters from point A of 6 kilonewton. So negative 22.929 minus again with 6 kilonewton gives us 28. Exaggerated yung figure ha, wag nyo na lang pansinin yung sobra-sobra. So we have 28, negative 28.929 kilonewton. Then, bababa ulit yan dahil we still have a uniform load of 2 meters. So, negative 28.929 minus 10 kilonewton per meter times the 2 meters, which is the rest of your uniform load, times 2 is 48.929. So, we have there negative 48.929 kilonewton. Then, note that there is a reaction at the roller support acting upward. So, negative 48.929, add the reaction, positive kasi siya, plus 86.429. Gives us 37.5 positive kilonewton. So that is positive 37.5 kilonewton. And lastly, subtract now the varying load. Varying load. Note that the varying load is already at a slope of first degree. So your figure on the shear diagram should be now in the second degree, which is a spandrel. Alam niyo kung anong spandrel? Anong spandrel? So this is your spandrel. So later on, we'll have to identify the area of a spandrel. Okay? So first degree, 37.5 minus the area of the varying load, which is a triangle, minus 1/2 of 15 times 5, base times height. 1/2 base times height. Basically ends at 0, which tells you or tells us that our shear diagram or the reaction that we have recently computed are correct. Lumabas ba na 0? Nakuha nyo yung 0? Hello?
Yes po, sir.
Yes, sir.
Yun puti, nag-shade yung figure ko. Ayan. Then, it will suppose and will always end up at 0. Okay? So, meaning, our shear diagram is correct. So, gumamit na lang kayo ng graphing paper or any measuring tool that would plot your shear and moment diagram on a much more clearer view. Okay? So, this will now serve as our shear diagram. We can now answer one of the questions. Two of the questions. The shear diagram, ito na yung ating shear diagram. Then, what is now the shear at point C? The shear at point C, the maximum shear at point C is basically, lagay ko na lang dito, the maximum shear at point C, Vmax at point C, is equal now to 28.929 kilonewton. Okay? So the maximum shear at point C is 28.929 kilonewton. Sinabi naman niya maximum shear. So pag sinabi nating maximum positive shear at point C, that is 0. The maximum negative shear at point C, that is 28.929 kilonewton. So yan na yung ating answer sa point C and yung ating shear diagram. So what's next? Anong susunod sa shear diagram?
Moment diagram, sir.
So for the moment diagram, how are we going to solve the moment diagram? So how are you going to plot your moment diagram? Note that all of your shear diagram at every span identified there are all in the second degree, ay on the first degree and on the second degree. Lagyan muna natin ng degree values. Yung ating curve sa shear diagram at 1 meter is on the first degree. As well, this one, and also this one. But the spandrel is now at the second degree. Note that the varying load is already in the first degree, therefore the spandrel is supposed to be in the second degree. Ano susunod natin kailangan before we continue is for us to identify the distance of this triangular, the base of this triangular figure at your shear diagram. Hanapin natin yan. Let's note that as x and note this as 4 minus x. How are we going to do that? Solving for x is what? Ratio and proportion. Solve for x. By ratio and proportion, at the x side, we have 17.071 is to x equal now to what? Anong gagamitin? 28 or yung 22? Yung gagamitin? Yung 28 or yung 22 for your ratio and proportion? Hello? Of course, yung 22. We have 22.929. Disregard the sign. Ratio and proportion lang naman yan. Of 4 minus x. By ratio and proportion, identify x. (22.929) over 4 minus x. X is now equal, for us to be able to solve the area of that triangle, 1.071 meters, while 4 minus x is equal now to 2.2929 meters. Okay? I hope nakuha nyo yung ratio and proportion. So, ilang area yung kailangan nating i-compute dito? We have area 1, area 2, area 3, area 4, and area 5. Okay, we have 5 areas to compute. So, let's start now plotting our moment diagram. Moment diagram, unit ng moment diagram is kilonewton meter. I'll be using this one. So what is the area of a trapezoid? Ano yung area ng ating trapezoid? Anong area ito? Anong area yan? Trapezoid, right? Oh, compute that area of that trapezoid. Note that there is no moment at the hinge support, so we will have to start at 0. Okay? Ano yung area ng trapezoid? 32.071 plus 22.071 over 2 times the base of 1 meter. Gave us 27 point, ang tawag na 27.071. First degree. So, yung curve, opening downward, upward, that is 27.071 kilonewton meter. Then, the area of a triangle. Area of a triangle, 17.071 base times height. So, from 27.071 plus the area of the triangle. Bakit plus? Note that our diagram are still on the positive quadrant of our figure. Positive, kaya times plus. So, 27.071 plus 1 half the area of the triangle with 17.071. Base is the x of 1.7071. So, tataas pa yan. Yan, exaggerated lang yung figure. So, that is 41.642 kilonewton meter. So, 41.642 kilonewton. Pero hindi ko na i-convert yung nasa calculator para dire-diretso. Next is to subtract the triangle on the negative quadrant. Bakit subtract? Dahil nandun siya sa negative side ng ating figure. So, minus the area of that triangle, 1 half of 22.929 base is 2.2929. 2.2929. So, anong mangyayari sa figure natin? Tataas ba rin ba siya or bababa? Gaganon o gaganyan? Pataas o pababa? So, anong mangyayari? Pababa. That is 15.355 kilonewton meter. Okay? Then, lastly, the trapezoid or your area 4 found in the negative quadrant. 15.355 minus the area of the trapezoid, 28.929 plus 48.929 over 2. Base is 2 meters. Tama ba? Oh, yeah. Base is 2 meters. Okay? That is negative 62.503. Okay? Exaggerated lang. That is now negative 62.503 kilonewton meter. Now, the tricky part is for us to compute the area of a spandrel. The area of a spandrel is basically 1 over the degree of the curve plus 1 times base times height. Yun lang yan. Ano yung ating spandrel? First degree, second degree. That is in the second degree. The area of the spandrel, that is 1 over 2 plus 1, 1/3. Base is what? 5 meters. Kikita niyo yan, 5 meters. Height is 37.5. Okay? So, 62, negative 62.503 plus, dahil nasa positive quadrant or positive side, 1/3 of 5 times 37.5. Basically, that is negative 0.003. More or less, that is 0. Ano yung magiging figure? Dahil yun ay pataas at spandrel, so dapat pataas din siya. Ayun, buti nag-close. Mas maganda yung figure. Which is now 0 also. Okay? So that will serve now as your, what do you call this? That will serve now as our what? Moment diagram. Now, the questions, what is now the moment at point D? So what is now the maximum moment found at point D? The maximum moment at point D, based on our figure, is 62.503 kilonewton meter. The location of zero shear, let's just say from point A. The location of zero shear from point A, VO. VO is what? X plus 1 meter. That is 1.7071 plus 1, or point of zero shear is at 2.7071 meters. Okay? Yun na yung ating final answer for this problems. Okay? And what if later on we will have another questions, a set of questions? The point of inflection. The point of inflection defines the point where on our moment diagram, moment is equal now to 0. Not the end part, but along the span of the beam. The point where moment is equal to 0 is called our point of inflection. Where the point of inflection also defines the location within the span of the beam of your maximum deflection. So sa point na yan, dyan daw natin makikita yung maximum vertical deflection ng ating beam. Wrong color. Yeah. Then, from there, we can assume that the deflection will be identified on this manner. Okay? So the maximum deflection is located here, delta, and also another deflection located here. Then you might probably ask later on the angle of deflection for your beams, especially when the supports are roller and a hinge support. But if that is a fixed support, the deflection of the beam should then be assumed on this manner. So pag fix, ganyan po ang deflection ng ating beam. Pag hinge at roller, ganito naman. Okay? Naintindihan po. Then, later on, you might ask the location. Might be asked the location of the maximum deflection from point A. So, again, ito naman yan. Solve lang natin to. Yung distance na yan. For us now to locate the maximum deflection or the location of point of inflection. Anong gagawin? That is 1 meter plus 4 meters plus what? Let's just say that is x2. Hanapin natin yung distance ni x2. So, by ratio and proportion, moment analysis, kunin natin yung area niyan. Area din yan for us to compute distance x2. Okay? Naintindihan po. So, that will serve now as your shear and moment diagram for this problem. Okay? Actually, I've already prepared a much more accurate figure for this one. So, para mas ma-appreciate nyo yung figure, if you're going to draw that in a much more accurate drawing or diagram, this is how it would look like. Nakikita po ba yan?
Yes, sir.
So, ito yung ating hinge, ito yung roller, ito yung uniform load na 10 kilonewton meter, concentrated load na 5 kilonewton 1 meter from point A, and another concentrated load of 6 kilonewton from 5 meters from point A, and our varying load of 15 kilonewton 5 meters from point D. As you can see here, tama yung ating shear diagram. Exaggerated lang yung nagawa kong figure. Pero, ganyan po yan. So, as you can see, we have the same values and the same diagram. Tama? Ako ha? Then, you also have our moment diagram. More or less, parehas din. No. Yeah. But the maximum deflection could then always be identified on the cantilever span of the beam. Okay? Pwede nyo i-screenshot yan. So, if you want to present your answers later on in a much more accurate diagram, scale nyo na lang po yung drawing niyo para mas maganda at ma-appreciate nyo yung shear and moment diagram. Okay? Yung inflection, lalo na itong deflection diagram, yan ang pinaka-importanting diagram na kailangan ninyong i-generate later on. Kasi from that diagram, pwede nyong i-exaggerate yung diagram na yan. Kailangan kong bawasan yung load. I need to revise the thickness of my slab. I need to change the material. If I'm going to use reinforced concrete, how about I'm going to add a steel component with my floor slab, concrete floor slab. What will be the reaction when it comes to the deflection of the beams? Will it reduce based on flexure? Reduce stress, and so forth and so long. As much as possible, the lesser deflection on your beam span, the better. To reduce strain and stresses within your structure. Then, less probability for structural failure. So, yan yung ating figure for this problem. Naintindihan? Naintindihan po ba? Hello? So I'll be presenting also next example later on para naman dun sa kabilang klase. Pero i-upload ko rin po yung same lecture para dito sa example na to. So on your own, try to answer this problem na lang. We have a cantilever beam, varying load, uniform load, concentrated load. Mas madali naman yan. Try to answer this problem, but I'll be discussing this particular problem dun sa isang klase naman para meron tayong lecture 1, lecture 2 example. No? Naintindihan po ba? Question. Sa example. Naintindihan? So based
Yes,
on the
sir.
shear and moment diagram, what if I'm going to ask you, what is now the maximum shear? What is now the maximum shear from the given example? Maximum shear. Ano yung maximum shear? Hello? That is 48.929 kilonewton. Okay? How about the maximum moment? Which is practically also the moment at point D, 62.503 kilonewton meter. Okay? Then later on, what will be the location of your point of inflection coming from point A or coming from point D? Kailangan yung isolve yan. Then the point of zero shear and the shear at any given point along the span of the beam. Same goes dun sa ating next example. Okay? Try to practice those figures and what is the difference on our diagram. Paano yung i-compute yung degree and so forth and so on. Oo nga pala, this is now on the second degree. Second, also in the second degree, but this one should be on the third degree of a curve. Yeah. Okay? So that'll be all for today, everyone. Save ko lang tong recording para ma-edit ko mamaya.